Hope everyone is doing great. In this video tutorial, I'll be showing you how to perform topographic wetness index or compound topographic index in ArcGIS. So what is topographic wetness index? Topographic wetness index quantifies terrain-driven variation in soil moisture. So it was put forward by Beven and Kirkby in the year 1979. So you can see the TWI is defined as log A divided by tan beta, where A is the local upslope area draining through a certain point per unit contour length, and tan beta is the local slope. So in order to perform or in order to calculate the topographic wetness index, we required DEM data or DTM data. So if you don't know how to download the DEM data, I have made a video on it, how to download SRTM DEM from USGS website. I'll be putting that link in the description, as well as I'll be putting the video in the cards. You can just check it out. And our next step will be adding the DEM data to ArcGIS. So after successfully adding the DEM data, we need to project our raster layer. So as you can see here, the second step, we need to project it from geographic coordinate system to the projected coordinate system. You can use the project raster tool, or you can just directly export it. So this should be done because we should avoid the greater negative values. So in order to get our results properly, we are using projected coordinate system, so that we won't be getting negative values while calculating the TWI. So getting back to the JS, here right click on this empty space and go to the option data frame properties. Here select the coordinate system and go to the option projected coordinate system. So here I am going to select UTM WGS 1984 Northern Hemisphere, and the zone will be 43N, and click apply and OK. Now just going back to the Word document, here you can just see the projected coordinate system for the entire globe. So here I am just doing it for this region. So it has been located in the 43 zone. So I have chosen 43. So if you want, you can just check out this image, and you can use this image for reference. So going back to the GIS, now we have set the projected coordinate system. Now right click on this image and go to the option data. Here once again select the option export data, and here we have to choose the spatial reference data frame, that is current data frame we are going to choose rather than the original data frame. And finally, if you want to rename it, you can just rename it. Here I am going to just rename it to projected, and hit the button save. So here you can see that it is asking me to whether it should be brought into this current work. So I'm going to click yes, and now I'm going to remove the previous image. So it is being projected to the PCS projected coordinate system. Let us move on to the next step. So the next step will be we are going to use the option fill DEM. Going back to ArcGIS, on the top you can find the option search, and here we are going to search for the tool called as fill. You can see here fill spatial analysis tool. Just click once. So this is the fill tool. Here we are going to input our projected raster, and finally we are going to rename it. So I am just renaming as fill. You can find some more information about this tool by clicking on this link. So you can see here fill sinks in a surface raster to remove small imperfection in the data. For example, in certain areas there might be gaps. So in order to remove such gaps or a sudden rise in value, or what to say, a sudden rise in a value or a sudden gap in the value, so that has to be filled. So that these are called as small imperfections. So that will be removed by using the fill tool. Now click on the option OK. So our fill has been successfully completed. Let me unselect the DEM. So now you can see, so we have removed the imperfections in this DEM data. So we just move on to the next text section. So the next will be flow direction. We will be calculating the flow direction. Once again, go to the search, and here type in flow direction, spatial analysis tool. You can see here. So here we are going to input our raster. Our raster will be fill, and we need to rename this file. So that will be flow direction, and click on the option OK to continue. So you can see here, this is our result, that is our flow directions result. So we just move on to the next step, flow accumulation. So you can see here, flow accumulation is the next step. Once again, go to the search bar, and here select the flow accumulation. So here on the top I have selected tools, so likewise you can select it, flow accumulation, so that you can easily find out the tools. Otherwise you'll be getting all the results. So I have chosen tools over here. So now select the flow accumulation, and the input is flow direction raster. We are going to input the flow direction raster which we have generated previously, and here we are going to rename it to flow accumulation, and click OK. For me, flow accumulation is taking a time because the area is big, and based on our system capacity the time will be taken accordingly. So you can see here, flow accumulation has been successfully completed. So this is our flow accumulation raster image. So we just move on to the next step. So we need to calculate the slope in degrees. So once again, go to the option search here. Search slope spatial analysis tool. Now our input raster will be our field data, and we are going to have the output as output in degree form. Slope in degrees, and hit the button OK. So this is our slope data. So we just move on to the next step. So we are going to calculate the slope in radians. So as you can see here, radians of slope, the formula is slope in degree into, you can see the constant value here, divided by 90. So we are getting this value because we are just what we are doing is that generally we are just transforming the slope from degrees to radians. So in order to understanding the concept, these are the basic requirement. For example, degree and radians are two units for measuring angles. A circle contains 360 degree, which is equal to 2 radians or 2 pi. So 180 degree represents a pi radians. So if you come in the GIS, so especially the maximum slope can be 90 degrees. So hence, for converting from degree to radians, so we are going to multiply it 90 degree into 3.14, this is the pi value, divided by 180 degree. So we will be getting this value. So let us do this step in the ArcGIS. So here, in order to do that, we are going to use raster calculator. So you can see here, raster calculator, spatial analysis tool. So we have got the raster calculator. So open the bracket, slope into this constant value which I have stored you. This is the constant value which we have got using this formula. So divided by 90. Close the bracket and divide it by 90. So we are going to just rename the output file, that is slope in radians, and click OK. So we have got the slope in radians, as you can see here. Now we just proceed to the next step. The next step is calculating the tan slope. So you can see the formula con. So slope. So this is the formula for calculating. So we need to just put it in this format in ArcGIS. So go to ArcGIS. Once again we are going to use the raster calculator, and here first we are going to use the con tool. So you can see here radians slope. So click on this radian file. Zero. And we are going to next input our tan. Double click on this. So we have got the tan. So once again we are going to add the slope radians. Going back to the formula, tan slope radians, comma 0.001. Comma 0.001. So it should be in decimal rather than it. We shouldn't keep it as 0. It should be having some values. So I am using 0.001. So rename it to tan slope and click OK to proceed. So we got an error message over here. Let us check what is the mistake. So I think we need to leave a space over here, and let me try it once again, renaming the file as tan slope 1. So let me remove this one and let me try once again. So let us run this file by clicking OK. and still we are getting the same error. Finally I found the error, so let me remove one bracket from here and let me add the bracket over here. Now let us run it. Most probably this time it won't be having the same problem. Hopefully this time we got the result. So we got the tan slope. So the next step, we are going to calculate the flow accumulated scale. So this is the formula: flow accumulation plus 1 into cell size. Once again, search raster calculator, open the bracket, flow accumulation plus 1, close the bracket, into cell size. So let us check our cell size. So let me right click on this fill data and go to the option properties. Here in cell size, you can just directly copy this value and put it over here. So now we are going to rename it to flow accumulation scale, and now hit the button OK. So we have successfully calculated the flow accumulation scale. So you can see the final step, that is TWI. So for that we are going to use the log function, flow accumulation scale divided by tan slope. Once again go to the search, hit the button raster calculator. So here we are going to use the log function, and let me go back to the formula once again: flow accumulation scale divided by tan slope. Flow accumulation scale, double click, divided by tan slope, and we are going to rename this file as TWI. So now hit the button OK. Yeah, we have got the result. So we got the TWI value. So you can see it is a positive value from 2 to 24. Go to the option properties. Here select the option Symbology. I am going to use classified, and I am going to select 6 classes, and let me change the color scheme. So I am going to use, let me choose a better color scheme. Yeah, I am going to use this color scheme. If you want, we can just classify it equal interval, or you can just leave it into natural breakings also. Click OK. Now just let me apply it. Click OK. So you can see here, this is our result. So let me zoom in now. You can see the difference. The higher value is having higher potential, lower value is having less potential of moisture, topographic moisture. So there the moisture will be relatively less, the value which is having a lesser number, having a lesser topographic wetness because of the terrain. So let me add the study area file, and let me clip So this is the study area file. Let me zoom in. So this is my study area. So in order to clip, once again go to the option search. Here, click, clip. So yeah, data management tool, I think so. So clip a data management tool. So in order to cut the raster, yeah, now let me input the TWI image, and here the output extent will be our study area file. Let me select the use input features for clipping and maintain clipping extent and click OK. So you can see the clip has been successfully completed. Now let me remove the file. Properties, once again, classify it. So I am going to use this scheme. Classify it once again. So I am going to use equal interval, and in the display I am going to use bilinear interpolation for continuous data. So you can see here we have successfully calculated the topographic wetness index. So you can easily prepare a layout map using this imagery. Let me show you that. So you can see here, this is the final layout map. So thanks for watching. If you have any doubts, please do ask in the comment section. I will be answering to your questions. Goodbye.